In predictive modeling, the dependent variable is also known as your y-axis or y variable. It's also known as your target, also known as your outcome. We use these interchangeably. So whenever someone says to you, what's the y? It's the dependent variable. Or what's the target? Again, that's the dependent variable. It's y. It's also the outcome. It's just different terminology, but that's essentially what we are trying to predict. Now, the independent variable is your x. This is your feature or predictor or input. And by the way, since I've said input here, we can also say that this, for the top, for the dependent variable, is your output. Okay. Now, when you're building a model, you have to take this into consideration. Let me do this so everybody could see it a little bit better. You have to take all of this into consideration. And so when you're building a simple model, we can start with linear regression and call this a single linear regression. And if you go back to, as far back to pre-algebra or algebra, whenever you've seen this first equation of the line, which is y is equal to mx plus b, you have m is your slope, x is your variable, b is the intercept, and y is what is equal to in the equation. But in this case, is what you're trying to predict. So it's a line. It's the equation for the line. And so when you're formalizing it, what you have is y hat, what you're trying to predict. So we just put a hat over it. And we have beta sub 0. That's your intercept plus beta sub 1, x sub 1, plus some error term bar epsilon. That's your residual. Basically the same thing. Your mx plus b is right here. That's the beta sub 1, x sub 1. This is your intercept beta sub 0. That's why it starts at 0. That's your b, and that's your residual. You didn't have that before, but that's how we formalize it. The only difference now as we move into the multiple linear regression model is we take everything from the single or simple linear regression model with one independent variable, and we just begin to add more independent variables into the mix. So now we have beta sub 2, x sub 2, and now we have beta sub 3, x sub 3, plus beta sub n for any number of independent variables. And it goes on. Well, not until infinity, but it has to be a reasonable amount because you can only have so many independent variables. But the idea is that you can have multiple independent variables, x sub 1, x sub 2, x sub 3, and so on and so forth. It's really the same equation. And your coefficients are here. Those are your betas.